We're on page 35 of our notes. What's today's lesson?
Probability of compound events.
Probability of compound events. So compound events, what do you think compound events are? More than one. So it's two or more simple events. Ready? Example 1. To do these kind, we can use a tree diagram. So we're going to use a tree diagram and chart to show both color and style of a car. The color options are blue, silver, red, and purple. The top options are hardtop or convertible. Everybody know what a hardtop is?
Yes.
Most vehicles have hardtop. Convertible is when the top comes off. Okay. So if I was picking a car, I could pick blue. And if I picked blue, I could pick convertible. I'm going to put a C because I cannot fit the word convertible in that box. Or I could pick a blue car with a hardtop. Raise your hand. What's the next option I could pick?
Oh, silver.
And if I pick silver, it could be a convertible, or it could be silver hardtop. Josh.
Red.
So red convertible, that would be my pick. Or red hardtop. Elijah, what's the last option?
Purple.
Purple convertible. I would never pick that. Or purple hardtop. That's a list. What we did was make a list. That's one option. The other option is a tree. And honestly, most people don't use it, but you will see it on STAR test. And when you see a tree diagram on a STAR test, it usually looks something like this, with things missing, and you have to figure out what's missing. So the first branch of the tree is the first options, which are color. So we have blue. What's missing?
Silver.
And
Purple.
the next branch is the top. So they have blue convertible or blue hardtop, silver convertible, silver hardtop. So what's missing? And you can abbreviate. Then what's the next branch?
Convertible. Hardtop.
And this over here is where you write the sample space. And sample space is basically the list. So this branch right here represents blue convertible. The next branch represents blue hardtop. What does the next branch represent?
Silver convertible.
And then the next one would be, and the next one. And the next branch. And then, okay, so how many options or possibilities did we get? 8. So those are 8. There is a faster way to figure out. If they just ask you how many outcomes or how many combinations, there's a faster way to get there. How many color options did we have?
4.
How many top options did we have?
2. 2.
2.
2.
And 4 times 2 makes?
8.
So if they ask how many combinations, you could just multiply. Questions? Okay, let's move on to example 2. If you toss 3 different coins, what is the probability of getting 3 tails? Complete the tree diagram to find the probability. So we're going to toss 3 coins, a quarter, a dime, and a nickel. If I toss a quarter, I could get either heads or,
Tails.
if I toss a dime, I'm going to get, is there something missing? Tails. This branch is missing, so I need to add that in. That will look like the STAR test. It'll be completely blank, and you'll have to figure out what's missing. Fill it in.
Also, heads is missing right there.
Right. If I toss a nickel, I'm going to get heads or tails on every branch, so I need to make sure that it says heads or tails. So heads was missing there. What else? Next one. What else?
Section for
So-
nickels.
Yeah. Look,
Right.
this branch is missing. The very bottom one. What's this called again? Sample space. And we need to fill in some of the sample spaces. So what would this one represent? Heads, heads, tails.
Right there in between, right there.
So
Head.
that one's going to represent
Tails.
tails because that was the first one, and then
Heads.
heads, and then the last one was heads. What else is missing?
2 bottom ones.
The 2 bottom ones. So what's this one represent?
Tails.
And the last one is so when I flip the quarter, how many options did I have for the quarter? It could either land on heads or tails. That's how many?
2.
2. And if I flip the dime, how many options are there?
2.
2. There's still 2. The dime only has a head or a tail. What about the nickel? 2. So if I want to figure out how many combinations, that's 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. 8. 8 combinations. And back to the question, it asks, if you toss 3 different coins.
Teachers, please pardon the interruption, but at this time, please send those students who are registered for the spelling bee to room 103. All students who are registered for the spelling bee to room 103.
If you toss 3 different coins, what is the probability of getting 3 tails? That's my event. Do you see where I have 3 tails? Where? The very bottom one. Any other place? No. So it could happen 1 out of 8, because there was an 8 total. Questions? Okay, you're not going to want to close your notes today because on the back there's some help for the questions we're going to do. So find your worksheet, please. Please write your name on your worksheet. Martine, read number 1. On the back of your notes is help for number 1. We're going to draw a tree diagram. If we spin this spinner the first time, what options could I get?
A, B, C.
Thank you. I could get A, B, or C. Wait, if you look on the back of your notes, it's already started for you. I wrote the first option. When I spin the spinner the second time, I'm going to get what? What are the options?
A, B, C.
So if I got A, I could get A again, or I could get B, or I could get C. If you're here in class, you have something that looks like this. I started it for you. So we're going to do so if I spin B, I get B the first time. What could I get the second time?
A, B, C.
And if I got C the first time, the next time I could get, okay, so this first branch represented A. The next branch represented A, B, and the next one represents,
A, C,
so what does this branch represent?
B, A.
B, A, B, A.
Please write it down. And the next one represents what? B,
C.
B.
Oh, B, yeah.
And the next one is C. And if you look, there's kind of a pattern. A, B, C, B, 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 A, B, C. What's this first one here?
C,
And the next one?
C, C.
And the next one?
C.
So our question, I know you're looking at it. I can't look at both papers at the same time, so I'm rewriting it. You do not have to rewrite it. Okay. So the question asks, what is the probability of getting at least one A? Of those options, circle all the ones that have at least one A. No, not all of them have it. How many? Out of?
9.
9. Okay, on your worksheet, number 2, this is on the back of your notes. See it? You can just fill it in there. You don't have to try to write it twice. Number 2. Christian, read number 2.
Draw a tree diagram showing the possible outcomes. What is the probability of getting at least 2 tails? What is the probability of getting 2 heads and 2 tails?
Okay, well, first let's complete the diagram. What's missing? Tails, right here. And this was the first coin. So this would be the,
Wait, they'll be right. Here we go. Right.
the second coin. What's missing?
And
Heads and tails down there at the bottom. And then this next branch would be the third column. We'll let some people catch up.
fine. Supposed to do this.
What's missing on the third option? At the bottom, there's a heads and tails missing. Now for the sample space. What's this first branch?
H.
4 H's. And so the next one's going to be anybody not seeing where I'm getting that? And look, we're just following the branches. H, H, T, H, H,
Oh, no.
H. So the next one would be H, H. Okay, the next one is H, T, H, H. And the next one's gonna be H, T. And then the next one, H, T, T, H.
It's just going in every possible order.
H.
It is. On this top one, all the first letters were H. And then we had 1, 2, 3, 4 H's and then 4 T's. And then H, H, T, T, H, H, T, T. H, T, H, T, H, T, H, T. There's the pattern. Look for the patterns. Okay, ready to do the bottom half? So all of these are going to start with a T. All of them. Okay, and for this top 4, the second letter is all going to be. So for the bottom 4, the second letter is going to be T. And then our branches get small. The third letter on the top 2 will be H. H. Oh.
That was the same up there.
Oh, we're missing this one. No, it's still T, H, H, but we are missing these. What should these be? So this will be H, H, T, T, H, H, T, T. And for the last letter, what do we write? HT, 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 HT. It's a big list. Yes. Now we're going to go back and look for at least, could it be more than 2 tails? Okay, so circle all the ones that have 2 T's. Parker, how many did you get with 2 T's?
Well,
Count again.
11.
11. Out of, how many total do we get? 16. Then the next question says 2 heads, then 2 tails. So it has to be HHTT. How many HHTT did we get? Mm-hmm.
1.
HHTT has to be exactly like that. How many do you see?
1.
1 out of 16 still. Questions? That's the biggest one we got today. Deep breath. Okay. Number 3. Richard, read 3. Okay, so we're going to toss a coin and do the spinner. And we're just going to make a list. We're not going to do a tree diagram. So if I toss the coin, what are the options for the coin? Heads
Or tails.
or tails. And then I spin the spinner, what could I get? Spin the spinner, what could I get on the spinner? Okay, so I could get heads and then E, or heads and then, we're going around clockwise. Don't do that to my brain. Heads and then E, heads and then heads and then, I mean, not win. Heads and then B. And it doesn't have tails to the side. So if I got tails, then what can I get on the spinner?
GCP.
Tails and then E, tails and then C, tails and then E, tails and then tails and then tails and B. And it just said make a list, so we have made a list. How many total outcomes are there? 12. So on the coin, how many options were there? 2. And on the spinner, there were how many options?
6.
And 2 times 6 makes 12. That's 12 total combinations. Questions? Noah, read 4.
The computer accessory that Chris is considering selling at her store comes in white,
Beige.
gray, or black, and has an optical mouse, mechanical mouse, or trackball. How many combinations of cutter and model machine stops in order to have at least one of every possible combination?
Okay, let's just look at the question. It asked how many combinations. It didn't say we had to make a list or trees. It just wanted combinations. And there's color. How many colors were there?
4.
1, 2, 3, 4 colors. Write that down, please. And then it says and model. So how many models?
3.
3, because we had optical, mechanical, trackball. So that's 3. What do we do with those to figure out how many combinations? And 4 times 3 makes 12 total combinations. Question.